solve a few of these equations now using these factoring techniques that we've been practicing. So this is the reason that we actually need these factoring techniques. And for solving most of these equations, we're going to use this basic idea that if you have something times something and it equals to 0, then that means that either one of those things is equal to 0 or they're both equal to 0, right? If you think about multiplying two numbers together, the only way you can multiply two numbers together and get 0 is if at least one of those numbers is equal to 0. Otherwise, you'll always just get another non-zero constant number. So we're going to use this basic idea, and you can see where factoring comes in handy, right? Because factoring allows us to write something that normally just has addition and subtraction and write it as something multiplied times something else. So let's see how this might work. For example, I could take this expression, x squared minus 4x plus 3 is equal to 0. This doesn't tell me anything. I can't really solve this equation the way it is. But if I can factor this, this is a class 1 or a type 1 trinomial where the leading coefficient is 1. So all I have to do is think about what two numbers multiply to get 3 and add to get negative 4. Well, that's going to be negative 3 and negative 1. Negative 1 times negative 3 is positive 3. Negative 3 plus negative 1 is negative 4. So I should be able to rewrite the left-hand side of the equation. And now that this is equal to 0, I can say that p times q equaling to 0 means that either p equals to 0, so either the first part equals to 0, or the second part equals 0. So what we've done is we've taken a complicated expression, complicated equation, and we've broken it down into two simpler equations. And then we just need to solve both of these equations simultaneously. So we actually end up getting two solutions for this equation. 3 is a solution, and 1 is a solution for this equation. This is the basic idea of how we want to work these problems. So another example would be something like this. 4x plus x squared is equal to 0. In this case, I can do my basic factoring by pulling something out to the front because there's a common term of x in both of these. So I pull out the x and I'm left with 4 plus x on the inside. All of that's equal to 0. Again, something times something equaling to 0 means that either the first thing is equal to 0 or the second thing is equal to 0. So in this case, we get x equals 0. We don't have to do anything to that. Here we'll find out that x equals negative 4. So my two solutions for this problem are x equals 0 and x equals negative 4. They should both work. Now remember, this only works whenever the expression is equal to 0. It doesn't work when the expression is equal to another number. So for example, something like this, the mistake that a lot of students make is they'll say, oh, I can factor this into x times x minus 1 is equal to 20, and then they'll split up and say, that means that x is equal to 20, and that x minus 1 is equal to 20, so x is equal to 20, or x is equal to 21. This is totally wrong. Don't do it like this. First of all, this doesn't make sense. Just because two things multiply together to get 20 doesn't mean that one of them has to be 20, right? 4 times 5 is 20, so automatically you can see this logic doesn't work. So don't fall in this trap. I tend to see students do this if they're not careful. But instead, what you want to do is get one side of the equation equal to 0. So I can do this fairly easily by just subtracting over the 20 from both sides. And now I'm dealing with a type 1 trinomial equation, right? So I can factor x squared minus x minus 20 fairly easily because I just need the two numbers that multiply to get negative 20 and add to equal negative 1. And those are negative 5 and positive 4. Now this is a good one because now this says something times something equals 0. I can split these up. X minus 5 is equal to 0. X plus 4 is equal to 0. So I get that x equals 5 or x equals negative 4. So I get my two solutions like that. So so don't make the original mistake that I was showing. Make sure that you always get it equaling to 0 first before you try to solve it. What about this one? This is also one where it's easy to make a mistake. 3x squared is equal to 27x. In this case, I would subtract over the 27x first to get it equal to 0. So just do some equation manipulation. And now you can factor a 3x out of both of these terms. So that will leave me with an x here and then minus 9 here. And so then I can split this up and say that 3x equals 0 or x minus 9 is equal to 0. So this means that either x is equal to 0, solving that equation, or x is equal to 9. These are my two answers for this problem. The mistake that people will make sometimes is they'll try to take this expression and they'll try to divide both sides by something that's in both sides of the equation. Now this is okay for constants, but as soon as you go through and divide by an x, one of your variables, we'll end up getting x is equal to 9, which is one of our answers, but the problem is whenever I divided by this x, I got rid of one of my answers. I killed off the x equals 0. So when you do it like this, you'll never get a wrong answer, but you might not get all of the answers, all of the solutions to the equation. So don't ever divide by the variable in a problem like this and divide a variable out of both sides, because you'll miss one or more of the solutions in the problem. Another example, let's see, something like this, 13x plus 4 is equal to negative 3x squared. Again, just add the 3x squared to both sides, and then you have it equal to 0. Now I should be able to hopefully factor this. So 3 times 4 is equal to 12, so I'm looking for the two numbers that multiply to equal to 12 but add to equal to 13. So this should be 12 and 1, right? 12 times 1 is 12, but 12 plus 1 is also 13. So I can, remember this is the type 2 of the trinomial, so I have to do that step first. And then I can rewrite my 13x as 12x plus 1x. And then hopefully factor this left side by grouping. So if I factor, I can group naturally here. I can factor out a 3x here, and that will leave me with x plus 4. And then here I can factor out a 1, and that still leaves me with the x plus 4 that I want, and then that's all still equal to 0. So now when I factor the x plus 4 out to the front, I have 3x plus 1. So x plus 4 times 3x plus 1 is equal to 0. That means that either x plus 4 is equal to 0 or 3x plus 1 is equal to 0. So I'll get two answers here. I'll get x equals negative 4, and solving this one, subtract over the 1, divide by 3. I'll get that x equals negative 1/3. So these are my two answers for this particular problem. Now in the notes I also have a couple of applications, so I'll just kind of run through those quickly. I'm not going to write the whole word problem on the board since you have it in your notes, but I'll go through. The first one there, it says you have two numbers. You have one number, and the sum of that number and its square is equal to 90. So the sum of a number and its square is equal to 90s. The first thing you want to do is just define a variable. We'll just let the number be x. So it says that the sum of x with its square, so the sum of x and x squared, so x plus x squared is equal to 90. So we just want to take that and rewrite it as an algebraic expression instead of a verbal expression. And then from here we should be able to solve this. This is really just x squared plus x, and then I can subtract the 90 over, and I have a type 1 trinomial expression. And so I want to find the two numbers that multiply to get 90 and add to get 1. This one's actually easier than it seems. it's just 9 times 10, right? Negative 9 times positive 10. So this should split up into x plus 10 times x minus 9 is equal to 0. So I should get that x is negative 10 or x is positive 9 for my two answers if I split those two up into individual equations. Now, if you go back and look in the problem, though, in the problem I ask you to only give me the positive number that this works for. A positive number plus its square is equal to 90. So in this case, I'll just boot out the negative 10 and just take the 9 and say that because the negative 10 is negative, we only want the positive answer in this particular problem. In the next application, I told you that there's a rectangle that has an area of 66 square feet, and then I told you that the length is the length is 5 feet longer than the width. Okay, so let's just assign some variables to this. Maybe we'll call the width W, and then we have the length here, and we know that if the area is 66, then that means that the width times the length is equal to 66 square feet. However, we can't solve this because there's two variables. So we use the clues from the problem that says that the length is also just 5 more feet than the width. So the length is really just the width plus 5, right? So I can actually think of this as the width times the length, but the length is really just the width plus 5, and now I have something that only has one variable in it. But this is still an equation we need to use factoring for. I can't solve this yet, right? Because it's not equal to 0. I got to get that 66 over. So what I'm going to actually do is distribute out this w and get w squared plus 5w. And all of that is equal to 66. Then I can subtract the 66 over. So I get w squared plus 5w minus 66 is equal to 0. And now again, this is just a trinomial that I need to be able to factor. Which two numbers, when you multiply, you get negative 66. Add them together and get 5. This should be a positive 11 and a negative 6. And all that's equal to 0, so that means that I can split this up and say that w plus 11 is equal to 0, or w minus 6 is equal to 0. So w is equal to negative 11, or w is equal to 6. Now in this case, we're dealing with dimensions, right? So in real life, we can't have negative dimensions. We can only have positive dimensions, so we'll just throw away that negative 11. This is an example of something that works in algebra, but doesn't necessarily translate into the real world. So it's kind of a leftover number. So we'll just take that the width is 6, and that means that the length better be 11, right? Because it's 5 more feet longer than the width. We can use that to figure out our last dimension. The last word problem I have in the notes has to do with a rock being dropped from a cliff, and it says if a rock is dropped from a cliff of 32 feet, then its height over time is given by this expression. So at t seconds, the height is equal to h. And the question is, when does the rock hit the ground? Well, when the rock hits the ground, its height will be equal to 0. So we can just plug in a 0 into our equation and try to figure out at what time t does this happen. So for this, I can, again, factor. I'll factor a negative 8 out of the front, and that will leave me with t squared minus 4. But t squared minus 4 is a perfect square, right? It's a difference of squares, I should say. T squared minus 2 squared. So I can actually continue to factor this into t plus 2, t minus 2, just using my difference of squares formula that we looked at earlier in the lecture. So this means that either negative 8 is equal to 0, t plus 2 is equal to 0, or t minus 2 is equal to 0. Now, for what t value does negative 8 equal to 0? Well, for no t value. So we actually don't even worry about that. In general, if you have a constant out in the front, we don't have to worry about setting that equal to 0. And it won't change the results of our answers. However, here, t plus 2 equals to 0. That means that t equals negative 2. And then t minus 2 equals 0. That means that t equals 2. So my answers are negative 2 and positive 2 seconds. Now, of course, again, this is an answer that doesn't necessarily make sense in the real world because we can't have negative 2 seconds. So I'll just say that 2 seconds is the only answer that we actually care about.